Hello students, today we are going to take up the topic here lab preparation and manufacturing of nitric acid, properties and uses of nitric acid. So let us start with a very good thought. Do not be afraid to give up the good to seek the excellent. The mean to say is, if you want to be an excellent, so you need to leave something good, very good. So we have to leave something to move forward. So learning outcomes from this topic is, you will be able to know, you will be able to explain about laboratory preparation of nitric acid, commercial preparation of nitric acid, which includes the contact process, and important reactions of nitric acid with copper in dilute and concentrated medium, and carbon and sulfur reactions with concentrated nitric acid, and along with that uses of nitric acids. Now let us start with the topic nitric acid. So you know that molecular weight is 63, formula is HNO3. So how to calculate the number of bonds? Earlier also I told you the method. Valence electron we have to count first, hydrogen having 1, nitrogen having 5, and 3 oxygen 6. So total number of valence electron 24. To complete the duplet or octet, because hydrogen is duplet is there, so 2 electron, and other case 4 into 8 32. So total 34 electrons are required to complete the outermost shell. So 34 minus 24 divided by 2 will gives us 5. So bond pair will be 5. As you see from this structure, Lewis dot structure, you can find that number of bonds are 5. Okay. So now lab preparation of nitric acids. We are taking here in the round bottom flask, we have taken here concentrated sulfuric acid along with sodium nitrate or potassium nitrate. One of that we can take of that salt, nitrate salt, and treat it with concentrated sulfuric acid, which on decomposition at temperature less than 200 degrees Celsius gives us the corresponding bisulfate, sodium bisulfate or potassium bisulfate, along with nitric acid vapors are formed. These nitric acid vapors, when cooled, it get condensed and we got the nitric acid in the lab. Okay, so here the method A is commercial preparation. Now the difference between lab and commercial is, this is prepared in large scale in industry. How? We are using two reactants, as you see from here, ammonia and oxygen. Okay, and ammonia and oxygen will produce NO, and this is a catalytic chamber where platinum gas is the catalyst. So now NO will react with oxygen. So here oxygen we are supplying in large excess, because it is used here, it is used here, it is used here also. So all the three chambers oxygen may be required, therefore oxygen is supplied in large excess. Now the point is, NO is converted to NO2 in the oxidation chamber, and in the last chamber, that is known as absorption tower, NO2 will dissolve in the water. Okay, and the waste gas is nothing but NO will be there, may be unreacted, that nitrogen will be there. So these are the gases which are there, so that can be recycled back after checking through the quality of the air, means the dust and all that should not be there, any impurities are not there, so we have to check, and it can be fed back into the reaction chamber. Quartz species helps in the absorption of nitrogen dioxide gas in water. It provides more surface area and it is corrosion resistant, and nitric acid will get in the absorption tower. So now here what are the reactions taking place? First stage, if you see, we have added what? Ammonia plus O2, but you see in the reactions we are using ammonia plus O2, and when we are taking the ratio when they asked, normally sometimes they will ask the ratio of ammonia is to air, then we are writing 1:8. Why? Because air contains 1/5 of oxygen, that's why we need to provide air in large excess, so 1:8. So 8 means oxygen is only 20% for that, 20 to 21%. So therefore the first reaction is 4 ammonia plus 5 oxygen give rise to 4 NO plus 6 water, because the air we are supplying, the nitrogen is not reacting, ammonia is reacting with the oxygen, okay, and nitrogen is acting as inert gas only. Oxidation of NO gives rise to NO2 and it may dimerize to form N2O4, and absorption of NO2 in the water gives rise to HNO3 and NO. NO, as I told you earlier, this is the waste gases we are getting that we can recycle it back. Okay, and the catalyst used is platinum. Temperature is 800 degrees Celsius and pressure is 1 atmosphere. This is exothermic reaction. Once the reaction started, large amount of heat will be produced, so we have to remove the heat, we have to maintain the critical temperature to get the maximum yield. So now nitric acid reactions with non-metal. If you talk of carbon, sulfur, phosphorus, these are the three non-metals where two of the reaction, carbon and sulfur, are there in our syllabus. If carbon is treated with nitric acid in the concentrated form, you will get carbon dioxide, okay, along with nitrogen dioxide and water. Similarly, sulfur when treated with HNO3 give rise to H2SO4, not SO2. Please do remember that carbon is oxidized to carbon dioxide, sulfur is oxidized to sulfuric acid, and similarly phosphorus is oxidized to phosphoric acid, H3PO4. And in all the three reactions, whenever concentrated nitric acid is used, you will get nitrogen dioxide as the byproduct along with water, because this nitric acid is not a typical acid, means it will not release hydrogen gas from the metal, it will release the water here. So water is there in the products in all the three reactions along with the carbon dioxide in the first case, and sulfuric acid in the second case, and phosphoric acid in the third case, and nitrogen dioxide is also common gas which is reddish brown in color. Now if you talk of metal, as we were discussing, it is not a typical acid, so metal plus acid normally gives hydrogen, but here no, water is obtained, so this is not a typical acid. So these two reactions are also very important, which deals with copper with nitric acid dilute and copper with nitric acid concentrated. As I have told you already, whenever concentrated nitric acid is used, NO2 gas will be there along with water. Similarly, if dilute nitric acid is used, NO gas will be produced along with water. Similarly, salt is same in both cases, copper nitrate. So you have to practice this balancing of this reaction. These reactions are very, very important. So please note this point. With the magnesium and manganese cold and extremely dilute, if nitric acid is very, very dilute, 1%, you will get hydrogen. It will act as typical acid only when we are treating magnesium and manganese, which are high reactive matters, with extremely dilute, means 1% nitric acid if you are using, then it will act as typical acid. So now uses, you know that nitric acid is used in the industry as well as agriculture. It is highly used in manufacturing of explosives, component of solid rocket fuels, and act as an oxidizer. It is used as a chemical reagent to identify various metals in the lab. So what we have learned so far is, let us see, nitric acid is prepared commercially from ammonia and air by use of catalyst platinum by Ostwald process. And absorption of nitric oxide is done using acid-proof quartz, which provides more surface area for absorption. Reaction of copper with dilute nitric acid gives rise to NO gas, whereas concentrated nitric acid gives rise to nitrogen dioxide. Concentrated nitric acid acts as an oxidizing agent, where carbon is oxidized to carbon dioxide, sulfur is oxidized to sulfuric acid, phosphorus is oxidized to H3PO4 phosphoric acid. Now let us try whatever you know, why nitric acid is not concentrated beyond 68%. So hopefully you may be knowing the answer. Answer is due to formation of azeotrophs, okay, at percentage of 68%. Next is, name the salt which is used in the lab preparation of nitric acid. That salt was nitrate salt and sodium nitrate or potassium nitrate. Reaction nitric acid acts as, in this reaction, Ki is changed to I2. So minus 1 is changed to 0. So it means oxidation takes place. Oxidizing agent nitric acid is doing. Nitric acid is acting as oxidizing agent. So next question is, name the oxide of nitrogen formed when freshly prepared acidified parasulfate is treated with dilute nitric acid. If you remember, this is a test for nitrate ion, and what is the gas produces? Nitric oxide. You know that the ring test. Ring test, why this NO is for? This is forming nitrosoparasulfate, which is giving the brown ring. And name the gas released when zinc is treated with 20% nitric acid is nitrous oxide. Please do remember, this is a special reaction of zinc, although it is not mentioned in our syllabus, but better to do that. These are the important reactions. Name the solution which can be obtained from nitric acid and used to dissolve noble matter. That you might be knowing, that is aqua regia. 3 volume of concentrated HCl with 1 volume of concentrated nitric acid. So congratulations, you have done all the right answers. So let us remember the thought, do not be afraid to give up the good to seek the excellent. Thank you.